Okay, could you hear me? Okay, perfect. So I want to talk a little about restoring the dumb fuzzing with a little help of disassembler. For me, it's a kind of new experience because all my talks before, like for all my years in the security community, was about researchers or at least trainings. But today I will talk about tool developed by myself. So it's a little nervous for me. Don't punch me in the face too much. And so who am I? I work as a security consultant for iActive. I hold PhD. In the past, I worked as assistant professor at St. Petersburg Electrotechnical University in computer science and security. And a small disclaimer, because it's open source project, it's my pet project. This work has no connection with my current employee, iActive. So just for sake of safeness. And here is the agenda. It's very simple. Why create another fuzzer? Because everybody needs to write his fuzzer once. But anyway, let's discuss it. So what's Erlamsa is about? And Erlamsa and radar. So why this talk is here? I need some basement, otherwise Pancake will be angry. So first, I'm not a developer and never have been a good developer. And you see there is a difference between a real software developer, like you see on this picture, who writes in C and uses VI or Vim. And myself, when I'm trying to develop something, when I'm using Erlang and write in using Visual Studio Code. But, as I've said, everyone should write his own fuzzer. That's every security researcher, security engineer at some point writes his fuzzer. So let's recap something about fuzzing. Currently, there are 3 possible approaches for fuzzing. It's generation-based, when we have some grammar, and based on the grammar, we generate samples. It's mutation-based, when we have some sample, and using mutation, we mutate it somehow randomly. And it's behavioral, either generation or mutation, like American Fuzzy Lob, which is a perfect software, which I use on almost every project, which actually do the thing like mutate or generate something, and then check how much code was covered, and then mutate again, cover another part of the code, and so on. And why we need another fuzzer, except that everyone should write one? So it's all about complexity with simplicity, because I very love this comic, and this is true. Because what usually happens, if you spend on the fuzzer more than 1 week in writing, it usually fails. That happens for me most of the time. You could either wrote some very specific fuzzer and use it and found 1 bug, or you could launch dump fuzzer from the first second and found 5 bugs, and you will be a noob, and I am a noob. Yes, I discover a lot of bugs. Most of my CVs or IC search CVs were discovered using dump fuzzer, so I'm a noob. I'm proud of it. The thing is, what dump fuzzer are you using, and how smart this dump fuzzer is? So I'm sure everybody uses and know Radamsa. How much people in this audience don't know Radamsa? A lot of guys. That's bad. You underestimate the power of dump fuzzing. So Radamsa is actually a test case generator for robustness testing, as stated by his author, Aki Helen. And it's a mutational-based fuzzing. You send something to Radamsa input, and you will get something weird on the output, some mutation of the input, which looks like the input, but differs. And if you send this data to target, and target is not perfectly written, and no software is perfectly written, there is some probability that it will be a crash or some unexpected behavior or whatever. So we have this magnificent tool, and we used it for, I think, 9 years already, because Radamsa, I think, 2009 or 2010. Why we need another tool? The problem that Radamsa is a standalone Linux command, like Linux program, which actually accepts data on the input and output either in socket or to the std in, std out, or to file. So every time when you need to fuzz some big target or fuzz it fast, you need to pipe Radamsa. You call it in a pipe, you run a new instance, and it's very slow. Especially, for example, once I need to, many years ago, like 5 years ago, I need to do some mutational fuzzing inside Android application. So actually it was an Android provider fuzzer. So what I've done, I've wrote the script in Python, which launched Radamsa on the laptop and then send results back to the Android. And it was a nightmare. So at some point, everybody thought about a great idea. Let's fork Radamsa. What's the problem here? Radamsa is written in old Lisp, which is a dialect of Scheme, a weird dialect. Radamsa uses a lot of lazy evaluations, which makes forking it more and more complex. And also Radamsa, the old Lisp, uses funny language, because this thing is evaluate lazy evaluation. Also there is lambda, also there is another Unicode symbol. So using Unicode symbol as a language constructions, it's so cool. Actually, I love Radamsa, really love, but I don't like this thing. And ask Anton. Anton tried to fork Radamsa. I think he also don't like it. So one does not simply embed Radamsa in his project because it's really, really hard. So, and if you fork Radamsa, what you want to edit? Of course, making integration with fuzzer easier, making work as a proxy or a service. Make it extendable, because adding a new mutation to Radamsa is a hell. Adding more patterns, adding some logging, generation-based extensions, and of course, Radamsa is single-threaded. We should make it multi-threaded. Honestly, I faced this problem 4 years ago. I think almost 4 years ago, because I think it was end of August 2014. When I need to fuzz around 100 components for 700 plus industrial field devices, and I have only 2 months on this project, and I was like, how to do it? So, and when I wrote the first prototype of fuzzer infrastructure, I saw the speed. The speed was awful. So I was really tired of forking Radamsa every time. I mean forking in case of calling fork function in C. So I've just forked Radamsa as a project to Erlang language and implemented it as a service. Why not C? Because it's impossible. Too many lazy evaluations. Why not a camel? I've tried. Really, guys, I've tried. But a camel is very strict language in case of typing, and Radamsa is very unstrict in case of typing. So after a couple of days trying to describe only one mutation using types, and when the project doesn't compile at all. So it just don't compile because too many type problems. Then I stopped, and then I said, what the? I rewrote it to Erlang. Why not Elixir? Because in 2014, there were no Elixir. Now, maybe if I do it now, I will rewrite it in Elixir, but the evil was already done, so it's in Erlang. Sorry, guys. So, but the result was pretty successful, because I found for 500 field devices were vulnerable to various memory corruptions, denial of services, and XML parsing problems. And all these bugs were found only by dump fuzzing, because I don't have more time and I need like some kind of fair coverage for each component. So that's how Erlamsa was born. And before I will show you the tool, let me just speak a little about Erlamsa versus Radamsa compatibility. So most of basic patterns and mutations from Radamsa works in the same way in Erlamsa. And Erlamsa uses common style, command line syntax and style mostly compatible to Radamsa in most features, but better consult the documentation first. But I'm trying to keeping the compatibility, so a new user of Erlamsa who used Radamsa before could just start from scratch. The only big difference from the basic notations that are in Radamsa and Erlamsa is in XML, because Radamsa is using XML parser, Erlamsa using SGML parser and fuzzer. Why? Because I faced a lot of languages that are not XML compatible. They looks like XML, but they are not XML grammar compatible. So I've used more generic grammar and tokenizer, SGML. And Erlamsa implements a lot of more features. So the installation is really simple. You just install gcc make and Erlang with some components. Then you clone, then you make, and here it is working. So let's see. I don't know. Is this okay? Should be. So if you run it like in this way, you will see nothing because it's an application that waits for some input. So let's try it in this way. And yeah. So it's kind of this. It prepares, so this is really cool, like r2con2018. So you see, it's just how it do it. First, it replaces 2 with 1, then it replaces C with another character, and he still keep the same form. So this is how mutational phase fuzzing works, and Erlamsa tries to keep the original of the fuzzing. And oops, is it mine? Maybe. Better I remove my phone from the pocket. Okay, so also you have like output it to a file, and then in the file you will see some output. Also you could like generate 2 or 5 and so on. And then you could output it into different files like r%n txt, and then you will see these are all files that were generated. They're big in the size. This is big, yeah, but it's a mutational fuzzer. It's non-linear in this way. Also, for example, if you want to see what actually happens, you could use various commands. For example, this one first gives you the random seed that was used, the same as in Radamsa, and output. And then if you want to repeat the result, you just use this, and you will repeat this result forever, like because you selected the seed. If you want to be more specific, you could use output of the metadata, which gives you actually the way how this result, this is not good result, let's do this result, like how this was got. So first it tries to insert some UTF and it fails, and then it tries SGML and it fails, then it actually removes some stuff, then it dropped some byte, then it tries to do some mutations, they all failed, and in the end he mutated some number. So actually we should, yeah, it's converted 2018 to 2019. So here you could analyze what mutations were done. Also, if you like, you could output to the whatever. For example, you could do like this, or you could do like this, and it should work. Yeah. In this case, to get the proper one, you should remove, of course, minus n, but yeah, it will work. So let's remove this. And also, you could specify any other output. So if we will look at the possible outputs here, you could see that it could be raw output, like we could output to the raw packet, which will be embedded in the Ethernet packet. We also could output at the IP level, so you could fuzz OSPF, for example, and I used it to fuzz OSPF. You could output to HTTP, also specify whether it will be GET or POST, the form, the parameters, the headers. For example, using this form, you could specify the headers, even the headers that will be in the outgoing query. It could be also a server. For example, you could use like this. Let me use date. And then if I connect to localhost and then type something, I will get something that was mutated by Erlamsa. So you could use it in any way you want with any output and inputs, not just limited in Radamsa. So actually it's like a tool that just ready from scratch, and you need 1 minute to start fuzzing. The next thing is Erlamsa as a service. What you could do is to run it as a service. So actually you specify the endpoint where it will listen. And I specify logging also. And then I could go, let me create another window. No. And then there are a lot of clients for it. It could be used from Node.js, from Python, from C#, and from Frida. So first let's try Python. So it's Python 2.7, and then like this. And you may see here, that fuzzer accepts some data and doing some fuzzing and also records everything. So it's very handy. Now if you need and how it is done, I will not use Nano because Pancake will be angry at me. So I will use Vim. Yeah. So it's very easy. We just create an HTTP query, HTTP post query to this address. This is endpoint address to this URI. We set content type as application octet stream, and we put the data that we want to fuzz in the body, and that's all. And similarly, you could do it using Node client. Yeah, you see. This is how it works. Also, you may have a question how to pass some arguments to the fuzzer if it's running as a service, like seed or some specific parameters. That could be done over JSON endpoint. So Erlamsa has 2 endpoints, the plain HTTP, which is very simple. You could even use curl for it. So just for handy stuff, where you send in body and you get the mutation again in body. This is JSON endpoint. So how it works, it sends an JSON object to the fuzzer. Actually, it has data field when you embed base64 encoded data. You have seed, for example, if you want, and you could send other parameters like pattern or whatever. And it's really, really easy. It's just a HTTP query with the JSON in the body, and that's all. So, and we could check, and here it will return the same results because we set the seed to 1 constant, so result will be the constant. So let's get back here, and I will wait. So also you could use C#. I will not demonstrate C# code to save time and also not to like enrage the audience, but you could use .NET. .NET or .NET Core, the example on the GitHub allows you to do it. Also, there is a Docker image. So you just build a Docker image from this Docker file and then just forward the port 1771 to the just forward the port to your host system and then just try it, and it will work the same. The reason why I don't like to use Docker here, and I'm not recommending it, because Erlang is very memory hungry. So your Docker image will need a lot of memory. But just for testing, it's okay. But if you will need like do more than 1,000 requests per second, then probably it will just crash because of memory, not enough memory. And the third mode, so we have standalone mode, we have service mode, and there is a third mode. It's a proxy. Let me show you how it works as a proxy. So let me run some server, and then we will try to connect to it. So now I'm getting all the same result, but then I could run, just a second, okay, no, let me run it from here. I could run Erlamsa as a proxy. So what I need is I set TCP, the endpoint actually that will be listening, and the endpoint that where we will connect, and then probabilities, probability of mutating data from server to client, and probability of mutating data from client to server. So you could fuzz either one side or another side, or both. So it's kind of like this, if I'm not mistaken. Yeah, now it works. And now if we will, oops, demo effect, it crashed? No. Ah, I just crashed it, okay. I mean, I just closed the tab with the simple HTTP server. So let me rerun it. Python -m simple HTTP server. Oh my god. No, please, Python. Demo effect, sorry. Okay, now it... Where is... Yeah. It kind of is. Okay. Here it is. Okay. It's running, actually. So it tried to cheat me. Yeah. I'm just create a loop. Yeah, so it's kind of this. Thank you. So as you can see, and if I add like -e, you will look it better. So it also tried to mutate the fields and everything. So basically, it's I'm using it every time I face some network service, because what you typically face in the real work, you have some client, you have some service, and you don't have time to analyze the protocol. Or at least you have it, but first you could start the fuzzer, and then you could start analyzing the protocol. And by the end, you find in the binary where the hell this protocol parser, maybe you will have some crashes. So, and it's just one line. So you specify from here to there, where to listen, where to connect, and also the probabilities. So let's continue. Documentation. So as every good open source tool, there is no documentation. Actually, there is. It's on GitHub, and it gives you the basics, like the same I'm explaining to you. I don't have time to write a proper documentation, but it's pretty big. Like, it describes all the stuff, like how to run, what modes, what options. So what else do you need? And also there is help. So there are plenty of options with, don't know, good description, I think, maybe not good. And there is also a list of all possible mutations, patterns, generators, inputs, outputs, whatever is used. So you could, and they are a little, it is a little bigger than in Radamsa, like twice bigger, kind of this. So, a word about architecture. So we have 7 basic blocks, input and output, which could receive from generators, I mean sockets or files or Studio service and proxy. Then the data goes to predicting patterns. Predicting patterns try to understand what the kind of the data we have. So maybe we could use some heuristics there. For example, one of predicting patterns is skipper, that actually what it is doing is just detect whether there is some header of the packet, which is constant, and try to prevent mutating of it. So we will mutate only body. Another, this is sizer. It detects the size inside packet. If it finds some field that could be the sizer of the body, then it mutates the body and fixes the sizer. So in this way, it also works with the packets with embedded sizers, and also it works with the packet with hierarchy. So where one packet have sizer, inside there is packet that have sizer. It will not work very good if you have hierarchy more than 3, but I think with 3 it works perfectly okay. Also, there are some models like trying to detect CRC, but they're not good. They're still not in production, only in dev. And zlib, so it will, and base 64. And I think when I have time, I just publish it because they're working. I think they are more or less stable and ready to publish. Mutating patterns, they are selecting how the mutators actually will be applied. So it will be one mutation, or it will be a series of one mutation, or it will be a set of random different mutations. The mutators itself, it's a different mutators that do something with the received data, from just changing numbers, changing digits, like it could be, if it detects that there is a number in ASCII, it will try to make it negative or very big or whatever. If it detects text, it will try to insert the special symbols or UTF or print characters, so typical Radamsa style. Also the same with binary. These are an additions. So typically Radamsa is more text oriented, Erlamsa more text and binary oriented. If it detects that it's binary, it will try to find some meaningful numbers and also apply the mutations to them. Sometimes not very successful, sometimes it's very successful and working, so it depends, of course, it's all about random. And outputs, when data goes back. Also there is logging system and monitoring. The logging is logs everything that was going on, including input data and output data. And monitoring, which actually you could use to monitor and restart the target. And there are external modules. Actually, they could be applied at 2 points. First, you could use custom mutator if you need it, or you could use custom post-processor. And we will discuss them a little later. So, small word on the advanced patterns and mutators. Let me show you an example. So actually, let me first show it using XXD. So this is, So this is some packet, and you can see that this is a sizer. Actually, this is a sizer which specifies the size of this block. And here is the header of the packet, here is the tail, and then we could just apply Erlamsa to it and specify, for example, sizer pattern and use XXD. And you can see that actually it added some stuff here. So the packet body was mutated, but it also correctly updated the sizer. If we will ask Radamsa to explain, then you can see that here the sizer pattern was worked, and it detected that the sizer has size of 8. Value is 25 bytes. It starts on 3 and ends on 29. So it's just as we expected. So that was our original packet. So the sizer worked really, really good. I mean, that works from the beginning of Erlamsa, so it's pretty good. Skipper works a little worse. Sometimes it's just don't understand what to skip. Some format detectors are a little weird, so I will show you how it's going now. So we have stable sizer and skipper, I think, and also ASCII and SGML predictors, and experimental base 64 CRC compressed data in JSON. And I have planned also the common format detector, something unifying some common formats, X500 because you need it for the certificates and stuff and all the hierarchical data, and also the compressed data, other algorithms rather than zlib. But these are all in plans. I think the second column should be integrated by the end of the year. The thing how I develop Erlamsa is 2 branches because I'm the only one developer. I have stable branch, which should work, like you download it and it works. Sometimes it crashes, but it works. And I have a development branch, which is private, but there are a little of code changes in the main tree, like almost nothing or like a couple of lines, which are easily ported. And most of the development done with the external models. And once external model working, I just put it in the main tree, and we're done. It's integrated. About logging and monitoring. Logging is very simple. You could specify is with -L option, and you could log to std in, std out, std to file in text or CSV format, to Mnesia NoSQL Erlang in-memory database if you want to log a lot of data. It could be useful, or to syslog if you want remote logging. Monitoring could be now done via 3 possible monitors. It's CDB, Microsoft CDB plugin for Windows system. It's Logcat ADB for Android, and it's R2 for OS X and Linux. And before going to monitors, let's discuss external models, or let's cook some pancakes. Actually, let's create a mutator that will embed the data inside pancake tag. Why not? So let's do it. Like I will embed radar in pancake. Sorry, radar 2. And so I've already have this model. It's called external muta, and it's part of the examples. And here it is. So yeah, Erlamsa tries to apply it in a different ways. So you see, sometimes it creates like this because it skips something on start. This is a skipper pattern working. You see, skipper pattern sometimes is just crazy. It thinks that radar 2 is a packet and RI is just a header of the packet. But because it's too small, the more data you supply, the better it works, of course, because the less data, heuristics doesn't work well on small data. And how it could be written? No, external. So it's kind of this. Actually, every model have name, should export for functions, which is capabilities, mutations, post, and fuzzer. In this case, because it's a mutation, all these functions are just doing nothing. Capabilities export that this is a mutation model. And then we create a new mutation with priority 2, our function make pancake, pen the short name and the description, and then we just create it like this. And actually, this is a mutation. So I don't know how many people here knows Erlang, but if you know Erlang, it's very simple to embed something here. So if you need some specific mutation, it's really easy. Other possible thing is, for example, if you need the custom post processor. For example, for an HTTP protocol, you will need to fix the CRC when the packet is ready. So you just, like, on post function, you call the specific function fix checksum, and here you write the code to fix the checksum. So it's very, very easy. And the same I've done for IP when I fuzzed IP on packets against embedded system. And also how you could tweak the fuzzing. There are several options. Let's start with ascent option. So imagine that you need, you fuzz some complex protocol, and you don't, and the first stage of the protocol is authentication. So you want the authentication to be correctly passed. You could use two parameters. First is ascent, which actually the coefficient that will increase the probability of fuzzing on every next step. So you could start with something really small, and then you increase, and then in the end you start fuzzing every packet. And then on next connection, it is repeated. Another possible way is to do it is bypass option, where you could bypass first 5 packets and start fuzzing on the 6 packets. So it's very handy. Also, you could change the block scale. This is a minimum block scale from which Erlamsa is cuts. So if it receives some data, it cuts it in a small data blocks, and the minimal size is 256. So the way how to make skipper works better, you could set block size here like 2, and it start, or 3, and it start to work it with a very small data, so it will not actually work. It's just pass it to mutator. But that's not a good solution, but it could be in some areas. So this is very flexible. Other possible stuff is related to the performance. First is sleep. So actually, if you have target that it does not accept too much data, for example, it's some weird embedded device that will just freeze if you send more than 2 packets in a second. So I saw that devices, believe me, they are real. So you set the sleep in like 100 or 1000 milliseconds and everything is working. And to performance, you could change max running time. So you could limit the fuzzing to some value. Now it's 30 seconds. No data could be mutated more than 30 seconds, but you could set it to 5 seconds, and then the worker will be just killed, and the fuzzer will just return the data as it without fuzzing. And also you could specify a number of workers. Typically it's like 10, but you could set 100, and if you have like 128 gigas of RAM, you could set 200 and get a very good performance, but it's it depends on you. Also, Erlamsa has the thing that called embedded debugger. So actually it's a normal Erlang interface for profiling, but it's I do a trick, connected it to the Erlamsa, so you could see the workers that are now working and the processes, and that makes debugging really handy if you are not understanding what is going on. But this is a standard like Erlang profiler, but I'm running it not from the Erlang process, but inside the Erlamsa process. So that's more. But you may want to use this function if you are debugging something. So I think let's talk about limitations. So minimum recommended RAM to run on Windows is 4 gigas. If you have less than 4 gigas in your Windows system, forget about running Erlamsa. It will fail because Erlang is very memory hungry, and on Windows it's like triple memory hungry because of unoptimizing. But if you have a lot of RAM, you will not like notice any drops in performance. Like 8 is perfect. Also on Unix platforms, you could not use ampersand symbol like this one. I don't know whether you see it. This one. If you run Erlang with this symbol, it will freeze and zombify. So actually, you will need to kill it. That's not good. So I was fighting how to avoid this. Failed. So actually, what I've done is added a special option, -d, -detach. So if you want to run it in foreground as a service, you just run it with -d, -daemon, or -detach. So like old-fashioned Unix style. And also IP and raw outputs doesn't work on Windows, and raw output is not working on OS X. This is a platform limitations. nothing I could do except writing a separate driver for Windows. Maybe I will. Let's talk about integration with Friday. And with Friday it's pretty easy because, let me show you. Let me run first it as a service. And then let me find some window. Here we want to, what we want to do, for example, is we want to intercept and fuzz the returning value of my strcpy function. So why you need it? It's a typical thing that in, for example, iOS, you have some custom client level of encryption, and you want to fuzz what's inside that encryption, not the encrypted stream. So you just use Frida to output it. Now you could integrate it with Erlamsa, like in a way of, so Python 3, kind of, yeah, example. So now you could see that it just gets the result from Frida and then fuzz it. And in that window, you could see that actually it's fuzzing. It receives some data and modify it. So how it works, the example JS just taken from Frida side. So what I'm doing is just sending data to the parent Python script and receiving the data again on the event. And for the Python script, I just implement a function called Erlamsa, which just do an HTTP post with data and gets back the result. And you don't need to run Radamsa here. You could just use HTTP. The most common and interesting thing here, and on message, I call this function. That's it. Why you want to use Erlamsa in service mode is if you have a Chromebook and then you have a server, you put Erlamsa there and call it from your Chromebook. And on the server, and you could do it like put it on one server and then many people use this, because every fuzzing is distinctive unless you specify the fuzzing ID, which allows you to work with monitoring and do some, we will talk right now about it, do some fuzzing based on the previous states. But in a normal mode, all fuzzing are distinct of each other. So it's just you could use a lot of users to work with one server and do it very efficiently, as fast as your network allow you and the RAM on your server. And integration with Radar, which is not working. And I'll explain why. Let me find, yeah, this is it. So what I'm actually fuzzing here is this small program, which is a single-threaded TCP server that just took, if you send him my name is Alex, it will say hello Alex. And of course, if you send something really big, because this server is really badly written, I run nano, Pancake will be angry, but he already will be angry after this demo. So it doing it really weird. So we could fuzz it like on the several iterations, it will crash. So what happened if I could do fuzzing like this. So I send my name is Sergio and select monitor with capital O option. So monitor will be Radar. Then it will run this application and it will execute this after much script. Actually, this script just kills the Radar because sometimes Radar is freezing, but you could select any after action. So this action will happen after the application is crashed. You could do nothing, you could like dump something, you could do anything. And then let me run the server again. And let me run fuzzing. And actually it crashed. And you may notice it. Because here you will see that Radar is attached. Then there were like 6 cycles of iteration. And then the crash was detected why the crash was detected, because the backtrace is something really weird. The problem is that what Erlamsa do in this situation, it could save the backtrace, preserve the backtrace, calculate the addresses, and then adapt. If this backtrace happens too much, like there are several same backtraces, it will try to exclude some mutations to find another crashes. Because what's the problem with the fuzzing, dump fuzzing? If you hit some very common error pretty fast, like on the first several hits, other errors and issues could be hidden. So Erlamsa tries to remove these mutations and use another mutations, but because the backtrace size is 0, and this is because, for strange reason, radar debugging is not working. Thank you, Pancake. And this is, actually, I will show you that this is a radar problem. I'm sorry. Because if I run it with r2-d dc, let me close this thing. And then if I send a crash sequence, then it shows process finished, but dbt shows garbage. And I don't remember the register. di, yeah. di is empty. Deal with it. Yeah, actually I was a little burned this morning and last week when I realized that this demo will not work, so sorry. That's why I put everything on Pancake. Now I'm happy. So you should never allow me to do it before GSOC. I will just go to train and never do this talk. And this bug will be never uncovered. I'm finishing. Some statistics on usage. So I used my tool in some researches. 31 bugs in industrial DTM components, 23 plus 4 in mobile SCADA applications, 11 bugs in mobile antivirus applications. They are all public researches. You can find them. I just don't want to refer them because this is unconnected to any vendor talk. For the industry, I'm using it on my current work. I use it on my previous works when I worked as a pen tester, when I worked as a security and QI engineers. More than 200 bugs found during 4 years. I think that's a good result. For a fuzzer, it's a good result. And I'm using this tool because this is the first tool I'm used with any project. Like, I got the device or a software, I understand how to fuzz. That's like in the first half an hour because you need to understand how to run software or device, which usually happens. Then I start fuzzer and I do reverse engineering on source code analysis. And while I do it, sometimes some crashes appears. And that's, I think, the most effective scheme if you have 2 or 3 weeks on a project. And sometimes in the industry, you have 2 or 3 weeks in a project. If you have half a year, of course, you could design your own super cool fuzzer based on generational approach. Or you could try to use AFL for the network applications, which is a nightmare, or for embedded, which is a double nightmare. Otherwise, stick to the dump fuzzing. It helps. If you want to contribute, just use it, report bugs. If you report bugs, please attach fuzzing input and last seed txt file. When Erlamsa crashes, it creates file called last seed, which actually contains the random seed. And if you just give me the input, I will not be able to fix bug because without a seed, there will be a probability that this bug will never happen with the input or happen in next 1 billion year. So, you know, I need a seed. A seed is what's specifying how the Erlamsa made its way on mutating it and crashing in the end. Ask for features, fill requests, and if there are any skilled Erlang developers that wanted to contribute, I will be very happy. I want to thank Aki Helen, the author of Radamsa, for a magnificent tool, Adam Crane for really useful advices on fuzzer design, and Pancake and the whole R2 community for the great inspiration on doing open source products, and that was actually why I decided to publish it finally as an open source project. Like the inspiration from Pancake, from Ole, and all of you. Thank you. Any questions?
Questions?
Nobody using fuzzers. No questions.
Yeah, I do have some questions, but I was trying to fix the bug now because I didn't have time before. It's almost fixed. Wait. So one of the things that I find out when I'm doing fuzzing, but mainly by hand, because I do my own specific fuzzers, is fragmentation, because many clients doesn't handle fragmentation properly because they expect to get the answer in a single packet. But if you answer with different delays, like because the client is doing some timeout in the packets and you send that like different packet sizes and then you fragment this data and so on, end up crashing. Do you have plans to support that?
Yeah, it is not supported yet. I have some thoughts connected with the sizer pattern, so maybe sizer pattern could have some feedback, and after some time, after some learning, I will try to wait more. But actually, you could also use the delay. Sometimes delay works. Also, Erlamsa working, it's if you limit the fuzzing time and also exclude heavy mutation, like you know that this is a binary data without XML, just remove heavy mutations. Sometimes, even for fragments, it works well. Like if you run with null mutation, it works. The timeouts are really, really small, so the server will never notice it. If you add some easy mutations like soaring or ASCII or numeric one and exclude the huge patterns, like a little tuning, it would also help. If you see that it's not working, like it's constant disconnect, but actually I haven't seen this problem really. Yes, I saw it a couple of times. Removing of heavy mutation helped. When I tried to do it in past using Radamsa, calling Radamsa from a pipe, it doesn't work because it's too slow. But yes, this is the thing but it's a really hard to fix actually, because it's like, I think inventing AI is more easier than this, because actually to do it, you need the AI that could predict stuff. So you need the fully predict to get rid of this problem completely. But for most systems, especially Windows sockets, well, they always love to do fragmentation. Like removing heavy mutation helps in 90% of the cases. That's how it.
So other questions that I have. I was missing also the JSON stream logging. I think that's why...
I don't like JSON, but I will add it.
Yeah, because I will probably hook a Node.js service, receiving the JSON stream messages to process and then filter that data to generate some other logs with the input and output.
It's a nice idea. Fill the feature request on the GitHub.
And also, last one, this talk reminded me a little bit to the Xiao talk. I don't know if you saw it, but he was like evolution mutator. And so I was thinking in having support for mutating disassembly, so assembly code for fuzzing assembler programs, so fuzzing compilers, fuzzing assemblers, but also fuzzing analysis tools and
yeah, you could
CPUs.
Now, if you have a like raw binary, you could supply and it will try to do something, but now it's not like adapted to the binary code. You know?
Yeah, but not being fully dumb, like modifying binary.
Fully dumped, I once fuzzed one microprocessor,
yeah, because for
microcontroller with some success. So it works if you do it fully dump, but of course it will not work against Intel, because Intel is very well tested already, but against something not popular, you could try it.
Yeah.
And if you try it and get some results, just let me know. I'm interested.
Yeah, instruction assemblers are pretty cool, but the thing is that you end up like having to write everything inside the same process if you need some more performance.
Yeah.
But yeah, at the end, you just want to stick to some specific instructions that are undefined or they are not specified by the vendor. So you want to compare that with different implementations of the CPU and.
Yeah, so it could be a nice idea. And also, what could be done? It could be just We could add a command to radar that actually reads some block, sends to Erlamsa, and write it back.
Yeah.
Could work.
So yeah, I will ping you later when I fix that.
Okay. Thank you.
This is just a Mac-specific issue. It works fine in Linux and.
Okay.
So, anyway.
So I was just unlucky of using Mac.
No, it's okay. Buy Mac. So any other question?
Hi, can you name some of the libraries or tools where you found vulnerabilities or crashes?
So, for example, I don't want to go specific vendors very well.
Well,
Let me tell like what was found in the first research done with Erlamsa. It was buffer overflows and memory corruptions in ABB libraries, in libraries from Allen Bradley, in libraries from, I think, Anderson Hauser, and I think it was Siemens. It was a very long time ago. So for the recent findings, I've just was curious and found some HFT. So it's a high frequency trading library, and like second heap overflow, but it's still not fixed, so could not just tell you the name. But there are little HFT libraries, so maybe you could find it.
And do you think they implemented their own parser, and this because this is
that's because you never implement parser by itself. Well, I have SGML parser implemented by itself, and it crashes constantly. And I'm not a software developer, but I haven't seen parser implemented well from the first second, unless it's written in Haskell or Camel, maybe. Kind of this.
Thanks.
Thank you.
Any other question? What?
Did you try to fuzz Erlamsa with itself?
Yes, of course. That's how one of the tests working. But now it's not working very well because now it crashes more because of some internal problems with incompatible of some parts. So it sometimes crashes. Also, it sometimes crashes on the bad user input in the command line, but it's not like a crash. I'm just too lazy to write a proper handler. It just writes an error and then throw a crash. I don't count it as a crash because there are so little community now, so I don't bother to work on it. I could work on more useful stuff. Once the community will be bigger, I will try to fix it.
Okay, can I ask why it consumes so many memory?
Because it's functional, and the way how Erlang virtual machine is working, it delayed garbage collector. So sometimes when it receives too much data to mutate, it consumes the maximum data before the garbage collector started to work. And that's the thing. If you limit the speed, the garbage collector will free the memory and it consumes. It's more problem of Erlang VM, especially on Windows. On Windows, garbage collector is a nightmare. But that was the expected problem. When I started this project, I expected this problem. It's not a problem for me. I could give 8 gigas of working for it, and I'm okay. So if you have 8 gigabytes, it works pretty well on every machine because it has some limits. I just don't want, because I could implement more restrictions in itself and the waits for the garbage collector, but actually it will drop the performance. Sometimes here it's compromise between performance and memory consumptions. I think for me, performance is always the priority. Yes, Ole.
Wait.
We were running Erlang on a server in a previous startup, and our experience was that since the garbage collection is per process, and it's so lazy, it will not start garbage collecting until it's run out of memory. What we ended up implementing is every X messages, we would GC voluntarily, and that would solve the problem, but then at the expense of performance.
Actually, if you run it with -d option in debug mode, it will manually call the garbage collection at some point, because otherwise the profiler doesn't work. But I calculated, so the drop in performance, I've estimated because it's a fuzzer, it's really hard to estimate the performance. But for example, the difference of the performance on heavy mutations between Erlamsa and Radamsa is just 2. So Radamsa is twice faster. But actually, if you run Radamsa by piping it, you lose all this speed. So it's more efficient to call over a network to Erlamsa. But if I implement constant garbage collectors, the coefficient is 4 and 6, which is I think I could not allow it. And now the memory is cheap. So.
Yeah, my impression is that you're supposed to decide when you want to garbage collect. So you have to do it yourself.
Yes, there are some. Yes, I have the internal dispatcher that manages the process, and if it if it is like idle state in a service, then it tries to call garbage collector. But the nature of the fuzzer, if you do fuzzing, there is no idle time. There are requests, 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 and requests. Yeah.
True. Thank you.
Any other question? Okay, thank you.
Thank you.